Hi, I'm Dr. Dave Hudson, and today I'm going to talk a little bit about the scary thing about graduating as an undergrad and not being employable. So, this is a really scary proposition. It happens to a lot of students, and the biggest thing that I end up seeing is that they've been ill advised. This is 20 years plus after I graduated, and man, this stuff is still happening. So, what I want to do today is talk a little bit about three things you can do to make sure that you'll be employable and ready to move on to the next stage of your career as a scientist. So, I'm calling this science advisor. Why don't I have a job? So, the three things I want to really go through are coming prepared to advising appointments. This is one of the biggest things that I've seen as an advisor. Students don't come prepared with a vision for their future. Getting experience, so getting experience as an internship in a lab on campus, in a job. These are incredibly important nodes in your network that will help you to get a job someday and to be able to continue to grow and explore the world of science and conservation. And lastly, going to a conference. This is about networking. And if there's one thing that was never really shared with me, it was the importance of networking and the fact that people from around the world are in one place, one time of year, and they're all in the same room. It's incredibly important to do your best to be in these places. So, talking about preparedness when it comes to advising appointments, uh, overall, it's good to have a vision of where you're going. If you don't have that, that's still okay. You can figure out the specifics of it as you move along, but knowing that you want to be a scientist or that you want to do something in particular, having an idea for what that looks like in 4 years is a really important prospect. Every single program has an advising sheet. Sometimes this is a physical advising sheet. That sometimes this is a virtual one within the learning management system. But every program will have an advising sheet that's been made based on the contents of the, the handbook that's been placed out and the contents of the course catalog when you came into school. So when the registrar looks to graduate you, they look for what you were required to do when you came in as a student. These advising sheets are meant to guide you through that. So they're meant to take it down and break it down into what you can take and when. You should fill this out. This is really important to come to your advisor with an idea for what you're going to take, when you're going to take it, and how this is going to fit into your overall plan. So generally, there are the major requirements. So you've got to take, for in this case, a marine biology program. You've got to take certain biology courses. You've got to take the core requirements of cell and ecology and evolution, molecular bio, and some organismal biology courses to a certain credit load. You've got to usually have physiology. And then there are certain flexibility within this, though, to fit your interests. And that's what you should be thinking about when you look at a course description and when you sit down with your advisor, should I take this or this? They're going to have a better idea of how to guide you for your specific program. In this case, for like a marine biology elective, you've got a lot of different things you could study. If you were going to study invertebrates like I did, you need to take a lot of invertebrate biology. If you're going to get into how organisms work and how they physically work, you're going to need something that's like functional morphology. So there's a lot of flexibility within these, but your program is going to be able to allow you to be prepared for the thing that you're going to be able to do later on. Every science program has a lab requirement, but you generally can't pump these up with on-campus lab work. And they let you get a couple of those towards your graduation, but you've got to do a lot of the coursework as well. So thinking about how this fits in with the other sciences within your program, as a biologist, I had to have a chemistry background. There is a landmine here in that if you decide, I just want to graduate, but organic chemistry is scary to me, oh yeah, you could take you know, inorganic 1 and 2 and then just take intro to organic and biochemistry, no problem, you'll graduate. Well, that's true unless you want to go to graduate school. If you want to go to graduate school, they look to see that you have organic 1 and 2. So I had to go back and take organic chemistry 1 and 2 because I had the goal of going to graduate school. I had already filled this out, but my advisor didn't pick that up. So it's really important that you talk to them about these different things, about what's the difference between this track or that track when it comes to my long-term goals. So knowing something about that and being able to ask the right questions in the 20 minutes you have with your advisor is really important. Uh, for our program, we had physics required as well. You're working in a physical environment. The oceanography requirement was there as well, and then you've got to be able to write as a scientist. On top of that, you also had lots of things you could take for general education requirements. You may also want to take a language. I took a language and was a Spanish minor as an undergraduate, which served me really well when it came to doing work throughout Latin America. And without that tool, I wouldn't have known that I would have been able to go on and go for a Fulbright application. These are things that fit in with who you are and who you want to be as a scientist or a conservationist, and they're not met on this course sheet. So it's important to meet the objectives of your program, but it's also important to know a little bit about what your individual goals are from a learning standpoint, so you have the tools to do what you want to do later on. Second piece of advice that I have is to get experience. Now, business programs will tend to directly line their graduates up with a program where they're going off to work in a company for the summer. They come back, they've already got those connections for when they graduate. Science programs are not as good at this. Being blunt, it's kind of on your own. So you're going to have to be a little bit more on top of things when it comes to finding a paid internship and look for paid ones first, and keeping in line with some things you may have on campus. When I was at the University of Rhode Island, we had this really great on-campus program called the Coastal Fellows Program. It was a paid summer internship. We worked with an advisor, and we got really great in-field experience and in-lab experience. This is not, oh, I've done an ELISA in the lab. In my lab class, this is I did ELISAs that will then be used for publication. It's considered different. It shows up different on your resume, and when people interview you, you'll have a little bit more to say about that. You'll have had some directed research, but you'll be able to talk about how you could be able to conceptualize your own work. There are lots of off-campus paid programs. I always recommend to my advisees this Rochester Institute of Technology site, which has a plethora. We'll see it in the next page. And the other thing that I'll recommend, because this is relevant to a lot of marine biology majors, if you want to work for an aquarium, you have to go and work at an aquarium. So the way into the aquarium and zoo world is, and working on the animal side of that, is actually working in an animal program's internship. Most of the AZA affiliate, the Association of Zoos and Aquariums, affiliated zoos and aquariums are right now trying to make sure that those internships are paid. Try to find a paid one. There are lots of other on-ramps into that career, but in my experience, to get a job in a zoo or aquarium, you have to have already had experience caring for animals. So that's a chicken or egg piece. Now's the time to get into that. The other thing I recommend is looking early for internships. If you want to do a summer internship, the good ones will typically have due dates in February. Some of them have due dates in January. The latest I've seen has been a late March due date, but most people like to have their summer interns locked in the early to mid-spring. So it's really important to realize that, so that you're looking the fall ahead of time and making sure that you've identified some programs that would be good for you and your program, and that you've maybe had a chance to bounce some of them off your advisor. These are really important too, because gosh, they can pay up to $10,000 for the summer. So it's worth it. And it's something that ends up being something that's directly related to advancing your knowledge as a scientist, advancing your ability to do more, and further expanding your network for future career prospects. So thinking about just the sheer volume of lists, this is Just the marine biology recommendations from that RIT site. It's a little old, but most of the co-op links still work. But this just is a visual for the kind of stuff that's out there. Lastly, the strategy that was really never brought to bear for me, but if you've got a good advisor or a good on-campus mentor, they will highly recommend that you go to a conference. For me, my first one was the Benthic Ecology meeting. That is a really great student meeting. It's great to be able to present a poster if you've done some work as an intern or in the lab on campus. And that is a really great way to start networking with your peers within the field and with potential mentors for graduate programs or even for jobs. If they're hiring a tech, that's where they announce it. Um, if you're up for a slightly bigger meeting, a Society for Integrative and Comparative Biology, SICB, would be one that I'd recommend. But there are a whole other set of conferences for different societies. I currently serve as the program officer for the Crustacean Society. We have a small mid-year meeting and then our regular meeting is within the Society for Integrative and Comparative Biology. So I highly recommend finding a way to get to these things. There's also often very much travel assistance to get students there. We want to keep students in the field, and realizing that, it's really important for you to take advantage of those options. So hopefully this has been helpful, and hopefully we'll be able to move you forward on finding a way to stay in science. Stay tuned. Talk to you soon.